I would like to invite Professor Liu Hao to present the NSSC research on the geostationary interferometric microwave sounder.
It's my pleasure to be here and introduce some recent progress on the GIMS project. We call it GIMS. Its name is geostationary interferometric microwave sounder. And I think this is an area I have already talked for many years with Dr. Chinowat, and I think we can have more collaboration in the future in this area. And my presentation will consist with these three parts. In the beginning, I would like to give a brief introduction on our laboratory, and then I will introduce the concept of our instrument. And as the last, I would like to give a perspective on the collaboration in the future. So actually, Maya's lab, the microwave remote sensing laboratory. This laboratory is a key laboratory associated with NSSC. And the history of this laboratory can be traced back to the first Chinese satellite Professor Wu just mentioned, DFH-1, and from middle of 1970s, and this laboratory changes the research direction from the satellite electronics to microwave remote sensing. So this laboratory actually is playing a leading role or pioneer role in the microwave remote sensing in China. And after this initiative, and I think this laboratory has been involved in many Chinese observation missions, like manned space flight program, and also lunar exploration program, and also the meteorologic and oceanic satellites. So far we have 82 regular staff member and 50 graduate students with annual enrollment less than 20. These are several achievements we have already done. The first is S-Chenzhou-4 unmanned spaceship. We contribute a multi-mode microwave remote sensor on board. And this is the first space microwave remote sensing instrument in China, actually. It's an experimental one, but it's the first one. And the second one is the Chang'e 1 and Chang'e 2 lunar satellite. We contribute a microwave sounder. It's a microradiometer on board this satellite. And it's also the first microwave radiometric sounding measurement of the moon from lunar orbit. And we also contribute instrument for the Chinese polar orbit meteorologic satellite. We call it FY3. We contribute a microwave humidity sounder, which is intended to measure the humidity profile of the atmosphere. So far we have already launched the 3 satellites, and the data of the second satellite, our instrument the data has already been operationally used by the European Center for Middle Range Weather Forecast. It means actually this means data quality has already reached the highest level of standard. And the last one is the oceanic satellite. We contribute a radar altimeter and also atmospheric correction microwave radiometer for this oceanic satellite. This is also a breakthrough of microwave ocean observations in China. And the payload performance and the data quality is similar or better than the international equivalents like NASA's JASON altimeter. And now I would like to go to the theme today. Actually, I'm working in for several years. I worked on this project, working in this area for geostationary microwave sounder. And we know so far the microwave payloads for meteorologic satellites actually are all on board the polar orbit satellites. We can see the polar orbit, the head of the polar orbit is less than 1,000 kilometers. And so far there are no microwave instruments on board the GEO meteorologic satellite. because GEO, the altitude of the GEO orbit is 36,000 kilometers. And so this is the status of the meteorological satellite so far. And for geostationary microwave sounder, so why we need it? This is the question. So the first is why we need the observation from GEO orbit. It's because the GEO orbit, from GEO orbit we can get very wide field of view, and we can also get the full disk observation. And we can also get continuous observation of rapid changing weather system like typhoon, like precipitation. And this is an example. The first three images at the top shows the three observation of typhoon by polar orbit satellite. So the time interval among each is roughly 6 hours. So we can see between each image there are lots of changes there. So the low Earth orbit satellite cannot capture this rapid changing of typhoon system. So that's why we need observation from GEO orbit. So the second question is why we need microwave things. Because so far we already have optical cameras, we already have infrared imagers on the geometeorological satellite. So why we need microwave? The reason is the microwave can penetrate the cloud, can see the internal structure, internal thermal structure, internal humidity water structure of the typhoon. So that is very important. We get very important information from this observation. So for Asian area, this need is actually more emergent because we know typhoon-related disasters cause a lot of damages in the east and also the southeast Asia every year. So this image shows the tracks of Pacific typhoon between the 1980 and 2005. So we can see the affected area cover all the Southeast Asia and also the southeast coast of China. So it is so important. Why so far we do not have it? It's because there are a lot of technology challenge here. Because the altitude of the GEO orbit is so high, so if we want to get enough resolution, enough spatial resolution, we have to build very big antenna aperture to get the required resolution. So this table shows that if we want to get roughly 50 kilometer resolution at 50 gigahertz, we need antenna aperture more than 4 meters. So this is very challenging. So this slide summarize the technology, the technical challenge here. Actually, this photo is a payload at the low Earth orbit. The aperture size is roughly 0.14 meter. It is a temperature sounder on board Chinese FY3 satellite. If we use the same technology in GEO orbit, we will need aperture size roughly 6 meter, and we also need to rotate it. So this is very challenging. And fortunately, we have a new approach here. We got a new technology here. We can solve this problem. We call it microwave interferometric radiometer. Actually the way we doing this is the real aperture antenna can be replaced by thin array antenna. So this is the image which can be seen from GEO orbit. The traditional way is we get a very small beam and scan it, and then we cover all the Earth disk. And the new approach is we do measurement in the Fourier domain. We measure the Fourier transform of this image, and when we acquire all these samples, we do image reconstruction on ground. We can recover all the Fourier disk image. So this is the principle of this technology. And this technology has been firstly being demonstrated by European Space Agency's small mission, but it is at the low frequency band, L band. It's mainly for soil moisture and ocean salinity. And in NSSC, we have a group on this technology, leading by Professor Ji Wu, and we started studying on this technology quite earlier in the 1990s. And so we propose, based on all the experience, we propose a concept for geo-microwave sounding. We're using a circular array. We rotate this array, and we can get the 4-disc image of the Earth, and also the evolution of typhoon. So we built a ground-based demonstrator. It's a proof of concept demonstrator between 2006 and 2011. So the image area is a small image field of view, 5 degrees, and this is the image results we have already got by this demonstrator. And this is also some other examples. So you can see a lot of details here. We also tested the spatial resolution by a point source, and we also tested the sensitivity, the noise of this instrument. And with this instrument, actually the president of CAS and also the Director General of Chinese Meteorological Administration will visit our center for this demonstration. And also recently we visit this. We also discussed with the Director General of European Space Agency on future collaboration. And with all this experience, recently we initiated a new demonstration plan on this instrument. The main endeavor is to enlarge the field of view and also make the demonstrator more compatible. It's more close to the spaceborne instrument. And between 2013 and 2016, we got support from Ministry of Science and Technology, and also support from CAS, also support from CMA. We got a lot of support on different aspects to develop the new demonstrator. And this is our new demonstration plan. It's mainly the temperature sounder will be implemented by the circular array, and the humidity sounder will be implemented by the traditional real aperture technology. And this is what it will look like in space. And this slide shows the expected in-orbit for this performance. So you can see the best spatial resolution is in the nadir point, 50 kilometer resolution, and also the radiometric resolution is also the best is in the center. It's this area. And this slide, I will skip this one. It shows the expected performance. And also we do a lot of work on the modular design of the system. The most concern is to make the system more compact and more close to the spaceborne instrument standard. So skip this. So for future collaboration with ESANT, actually, just as like Jill mentioned, personally I met with Chinamat quite a long time ago. In 2007, there is a workshop concentrated on geo-microwave remote sensing. This workshop is held in Beijing. Its main topic is on geo-microwave sounding. And last year, 2013, Dr. Chinamat Surusabadi visited us and to discuss the detailed collaboration plan in this area. And we signed minutes of meeting. We discussed the potential collaboration area, which things we can do together. So we also get agreed plan to initiate the collaboration work. So actually, for our laboratory, we are focusing on the instrumentation technology, and for ESANT, it's more focusing on the metrological application. So I think the work of the two sides are highly complementary. So we can get we can pave a way for the future collaboration in this area. So I use this slide to summarize my presentation. So the need for a geo-microwave sounder is emerging in Asian area, especially for typhoon monitoring. And in NSSC, we propose a new instrument concept named JIMS for future Chinese next generation meteorological satellite. We call it FY4. And cooperation with PSU is fully welcome. So, okay.
Thank you, Professor Liu. I would like to invite Professor Chinawatra Sawadi, the Director of ESAN, to present ESAN research and academic activities.
Director of the ESAN. And first of all, I'd like to say that I'm very pleased for this event to happen, and I think it's gonna generate the development of the space and technology, space science and technology. I'd like to introduce briefly about the ESAN and the research activity. We have been established in last year, February, and the goal is to develop the knowledge, technology, and personnel to help solve the environment and natural disasters problem at local to global scales. And right now we have the academic programs. The first one is the MPhil and DPhil in Earth System Science, started in August last year. And we are having the M Research and M Master of Science in Natural Disaster Management, which will start this August. And this is the opening ceremony by the PSU President and former Phuket Governor on July the 4th last year. And our faculty members have won several international and national awards. And the first one is the Gold Medal Award from the 8th International Exhibition of Inventions in China, and Leading Innovation Award from that same International Exhibition of Invention. And we have won the 2013 Outstanding Research Award in the field of engineering and industrial research from National Research Council of Thailand. And we have won 2012 Thailand Young Technologies Award from the Foundation of Promotion of Science and Technology under the patronage of His Majesty the King, and won the 2007 Excellent Doctoral Thesis Award from the National Research Council of Thailand. These are some of the awards that we have received. And for the our graduate programs, we are having the graduate students from other countries. With the help with the Indonesian ambassador to Thailand, we went to Banda Aceh last December, and we have recruited 4 students to come here this year. And these are some examples of our research, and I will just go briefly to the product and how it's going to help our country and our world. And the first one is development of the satellite passive millimeter wave precipitation retrieval algorithm. This is the collaboration with the Professor David Stein at the MIT. We can provide precipitation data all over the world. That's the rain and snowfall data. The algorithm is called EMP. It's the most advanced algorithm in the world. It's the first algorithm that can retrieve precipitation over sea ice. For example, this is the first Arctic precipitation map. This is the sea ice, this is the light pink in the background, and this is the storm over the sea ice. We are the first that can do this. And we can provide the amount of water that's coming. For example, this is a typhoon that's making the landfall to Vietnam. And we can provide global precipitation statistics that will be very useful for water resource management. And we validate that our retrievals over snow-covered land and sea ice are real and very accurate. And we compare with the global rain gauges, and we get pretty good agreement over the world. And our precipitation products have been listed in the International Precipitation Working Group website, which has several precipitation data, important precipitation data over the world. And we provide other parameters, including precipitation rates and amount of rainwater in the atmosphere, snow water, graupel, different species of the hydrometeors in the atmosphere. And we have used that to answer some of the natural disasters problem in this region. For example, this is the Mekong drought in 2010. We are using the satellite retrieve precipitation try to answer why we have that lowest level of the Mekong River in that time. And this is the flood in the big flood in Thailand in 2011. And we developed the precipitation retrieval algorithms for other satellites as well, and including the geostationary infrared satellites that can provide frequent observation but less accurate. As Professor Hao just said, that we are looking for moving forward the microwave geostationary satellite. And we have developed the high-resolution weather forecasting model for the tropics, which is very difficult to forecast in this region because the most precipitation in this region, most clouds have been developed by the convection, which the lifetime is very short, the time scale is very short. We compare this satellite observation and we get pretty good agreement. For example, is the satellite observation on the third column, and the fourth column is the forecast. And also we work on the microwave spectrometers for the satellites, and we have the model simulation that can predict the performance of the satellite spectrometers in advance. How are they going to perform? And that will save a lot of money and a lot of time. Including the geostationary microwave sounders. And we developed the flood forecasting system for Hat Yai region. And this is the comparison between the observations and the forecasted water level in that region, and we get pretty good agreement. And we also work on the climate change, global warming. We evaluate the sea level rise impact to the Thailand's Andaman coastal region. Big concern is on the Antarctica ice sheet, as shown in this figure. And we can see that this region is the area where the land below the ice sheet is below the sea level. So the collapse of some part of the ice sheet will trigger the whole part here to come to the sea, to the ocean. And if that occurs, then the sea level will rise as shown in this map. And in Thailand region, the sea level will rise about 3 meters. So we evaluated the effect for the Andaman region. And this shows an example of the Phuket. Okay, when the sea level rises 0.5 meter, 1 meter, 2 meter, 3 meter, 4, and 5 meters, where the red color shows the flooded area, flooded land. So we will lose a lot of land area, particularly in the coastal region where we have a big tourist industry. And here are some references. And the last thing I'd like to talk about is from the work that I have presented, and we have developed the website called worldmeteorology.com and the mobile application for the Android and iOS devices called WMAPP as shown in this figure. You can provide weather forecast for Southeast Asia region for 24 to 28 hours in advance. And we get into the very detailed, high detail forecast, weather forecast, and it's the first time that we can provide this high resolution and high detail every hour in advance. And this application also provides the satellite retrieve precipitation over the world, and also we have pull the data from the USGS to report the global earthquake. But other products have been developed, have been produced by using our model and algorithms. And from May 2014 to now, the website has more than 45,000 users with the 255,000 page views. And from April last year to now, the WM app for Android devices has more than 32,700 downloads with the source scores from user of 4.2 from the total score of 5. So that's about 84% from the 100. And the iOS device from October last year to now, we have more than 11,000 downloads. And it has been in several news. Recently in December 2nd last year, we have the Princess Songkhla University have signed the MoU with the TNN Thailand Digital Television Channel that to collaborate with using the information from this application for their weather program to broadcast 4 times per day. And we are right now working together to get our information to the production. And we should be ready sometime in this February. So if that happens, it's going to be the first time in Thailand that can provide accurate and high resolution, high detail, when it's going to rain and where it's going to rain. Okay. And this is an example of the precipitation rate for Southeast Asia. And this is the wind speed and direction. And we are extending the forecast to cover all over the world. Right now, we are working on the European region, and we are trying to. Our ultimate goal is to cover all over the world, and that will be very useful. And this application won the invention awards that I talked earlier from China. And this April, we have been invited from the National Research Council of Thailand to attend the competition in Geneva, Switzerland in this April. So I look forward for that event.
Thank you, Professor Chinawat. It is now the opportunity time for the signing of the MoU. I would like to invite the PSU Vice President, the Director of NSSC, Professor Liu Hao, and the Director of ASCENT to sign the MoU.
Yes, sorry, the president has to leave. You can sign later. Otherwise, you have to reproduce it.
So we keep one original and you keep one.
Yes.
Okay, video. Yeah, and then we'll see after and send one. Real copy to us.
Yeah, okay.
Put the governance upload and then
All this.
Okay, we take a photo together.
Okay.
เราเอาคำนี้เอาของห้องของไปมาว่าก็ต้องกลับด้วย ตรงนี้ครับ
เชิญครับเชิญครับ
ASEAN actually prepared some tips for the NSSC representatives. Now, the MoU signing ceremony event has completed. I would like to thank all the distinguished guests for attending this event.